All right, let's look at the homework 13.1, problem number 9. All right, so we have two curves given, and we want to find the point of intersection first. All right, so let's do that. All right, so first curve is R1. All right, R1 of t is equal to, so you have t comma t squared comma t cubed. Right, a second curve, right, and since they do not have to go through the same intersection point at the same time, so I'm going to have to use a different letter S. So it's going to be 1 plus 4s, comma, 1 plus 16s, comma, 1 plus 52s. Right, so from there we can get a bunch of equations. So we have, right, first one is t is equal to 1 plus 4s, right? And then t squared is equal to 1 plus 16s, and t cubed is equal to 1 plus 52s. All right, so I'm gonna work with the first two, and let's see, I'm gonna multiply the first equation by 4. The reason is I can match if I turn 4s into 16s. So you're gonna have 4t is equal to 4 plus 16s. All right, then we have a t squared is equal to 1 plus 16s, right? Then we can go through a subtraction between these two equations, and we have 4t minus t squared is equal to just 3. All right, so we have a quadratic equation that we can solve. So this is going to be, all right, I'm gonna add the t squared and subtract the 4t. So we're gonna get 0 is equal to t squared minus 4t plus 3, which can be factored out as quantity t minus 1 times quantity t minus 3. All right, so from here we have a couple of t values. So t is equal to positive 1 and a positive 3. All right, so when t equals 1, the point is going to be, so we put 1 here, 1 here, 1 there, so it's going to be 1 comma 1 comma 1. All right, so we have to make sure that this is actually true. So when 1 plus 4s is equal to 1, so s is going to be 0, so this is going to be 1, this is going to be 1, so it's going to go through the same point. All right, let's try t equals 3. So it's going to be 3 comma 3 squared 9 comma 3 cubed 27. All right, so if let's see, 1 plus 4s is equal to 3, so s is going to be 1/2. So if you have 1 plus 4s times 1/2 gives you 3. 1 plus 16 times 1/2 is 1 plus 8, so it gives you 9. And 1 plus 52 times 1/2 will be 1 plus 26, so 27. So it goes through the same point. All right, so let's type this guy in. All right, we got 1, 1, comma 1, comma 1, and also 3, comma 9, comma 27. All right, so let's go ahead and check the answer first. All right, it came back and looks like we got the first two correctly. All right, last one. Find the time when the particle collide. All right, so this actually is a little bit harder than having an intersection because they have to be at the same location at the same time. So the t has to be the same as well. So in this case, we can just set these guys equal to each other. So all right, so t has to be equal to component of the other guy is 1 plus 4t. All right, so this will give us, let's see, subtract t and subtract 1. So it's a negative 1 is equal to a positive 3t. Right, so divide through by 3, we can get t to be, I'm going to flip these, negative 1/3. Right, then if it's a negative 1/3, second component of the first curve will be t squared. So t squared is equal to negative 1/3 squared, which is going to be 1/9, right? But if you look at the second component of the second curve, will be 1 plus 16 times t, so it's a negative 1/3. So this is going to be, let's see, this is going to be 3 over 3 minus 16 over 3, so it's a negative 13 over 3. So you can see that these two guys do not match up. Right, so if you try to match up the first component, second component never matches up. So these two particles will never collide. So I guess it does not exist. All right, so here, let's type in D, N, E. All right, so let's check the answer. All right, I came back and looks like we got this one correctly as well. All right, that's it. I hope that this was clear.